Hello, I'm just trying to, I'm a little bit backlit, aren't I, by the sun. Maybe that doesn't matter once I share my screen. How are you all? Hello, hello, hello. Year 13 is in an hour. Yeah, we're going to be doing basically the rest of differentiation. I'm going to be doing in 1 action hour. I'm going to be doing the chain rule, product and quotient rule, implicit differentiation, parametric differentiation, connected rates of change, differentiating inverse functions. Boom. It's going to be great. But for now, we are doing trig. And if there are any second years in here, you can inform the first years that I'm not lying when I say that trig is one of the biggest topics in the second year, and that nailing it down before September, before it gets crazy, is definitely a good idea. So I hope this is going to be something, this action hour is going to be really, really useful for you. Right, let's get screen shared and timer on and focused work. Actually, before I do that, I should probably remind you that in the exambulance, I'll just show you that quickly, just in case you want to know where all these things are. Okay, so that's the content guide. That's the exambulance, right? If everybody should have their exambulance in a tab open ideally, so that you can reference where everything is. This is where we're putting everything that we're doing basically. So the schedule that we're sticking to is in the study schedules bit here. And at any time, if it seems appropriate for us to change the schedule, if you guys want to do something different or have a different style, then we will change it up. But these are the schedules as they currently stand. The course maps that we're working through, first of all, on Monday, we went over the whole course map for the pure, for the first year and then for the second year, and then we chose some priorities for this week. At the beginning of next week, we'll do the same thing for the applied, for the stats, and then for the mechanics with the first years. You can see that on your schedule. In terms of the revision notes, what I'm going to be doing is giving you a playlist in every session, and that playlist corresponds to tutorials that are in the content guide. Now, you've got access to the content guide. If you've got a subscription, you've got access to all of it. But what I'm doing is every 24 hours, I'm making free the ones that you need for this session. So for example, what we're doing now, trig. So if you click on content guide, all of the trig is going to be available to you, even if you don't have a subscription. That's for the next 24 hours. And for the second years, all of the differentiation that we didn't do yesterday, that will all be available. In addition, you can click here and see the overall revision notes. So this page here covers everything you need to know about differentiation. We do the first year bit first, and then I say what the end is, and then it's the second year bit. And if you click on this, it will take you to the video where we went through these notes and filled them all in. So it's lots of flexibility with how you can work with it. Any questions about the exambulance, how to get it, what's in it, etc., just shout. I'm sure you'll be able to help each other out, and also I will be able to help out if there's anything you're not sure about. Okay, so here is the plan that we went through on Monday. And yes, vectors, Andre, we're doing, if you look at the schedule in the exambulance, vectors is scheduled in for Friday, so we'll be doing it then. Right, we discussed on Monday, this is all of the AS pure here, and what we discussed we were going to be doing today and yesterday. Yesterday we did the exponentials. We haven't done linearizing data with logs. That's quite a big topic really, so we're going to do that tomorrow. Today we're focusing on the trigonometry. We're going to cover basically everything in the trigonometry, okay? So first years, it seems like there's very little for you to actually know. You have to know what sin x and cos x and tan x actually are. Oh my goodness, I didn't put my 45-minute timer on. I've broken all of the rules of action hours. The rules of action hours are that we have to have a timer for 45 minutes and we have to stop when it says stop, and then take a 10 or 15-minute timed break during which we stand up and walk around and go in different rooms. And the other rule of action hours is that we have a clear target, not just revise, work on, look at, nothing like that. So here is the timer on. And the clear target is that we're going to go over and create a set of notes on everything you need in the first year for trigonometry A level. Okay, so sin x, cos x, tan x, what are they other than buttons on the calculator? what do the graphs look like? And then maybe you'd have to apply graph transformations to fiddle around with them, but what are the basic graphs of y is sine x, y is cos x, y is tan x, what do they look like? And then you need to be able to solve equations and prove identities. So the equations that you need in the first year are just these two, that's it. Usually the sine squared plus cos squared is 1, we rearrange. So we do sometimes use it as sine squared plus cos squared is 1, but it's usually sine squared replacing it with 1 minus cos squared, or cos squared replacing it with 1 minus sine squared. Sine over cos is tan is the only other thing you need to know in the first year. And usually we generate, sometimes that pops out in a proof. You'll go, oh, there's a sine over cos, I'll make it tan. Or maybe there's a tan and you make it sine over cos. But usually we generate this ourselves by dividing everything by cos x. So there isn't a cos x on the bottom of the fraction. There are no fractions, but because we divide everything through by cos x, we then create the sine x over cos x, and then we can change it to tan x. So the playlist for today is very small. It is 2 videos, and then really trig is much more about the application and the practice than about the theory. I'm just going to move right a little bit, so I am slightly less blinding you with the sun behind me. So we're just going to jump straight in. Those are the only 2 things you have to actually know, and we're going to jump straight in and see how much of that you already know. Now, I think everybody has learned how to solve trig equations, okay? I think that is going to be, I mean, let me know if there's anybody who hasn't done solving trig equations with their teacher during the first year of the AS yet, tell me. But I really, really don't think that's going to be anybody, because teachers tend to work through the book, and trig is more early in the book than other things, and I think pretty much everyone's covered it. I have a different way than pretty much all teachers of showing you how to do this, okay? But if your method works really, really well, we're going to stick with your method. If your method doesn't work really, really well, I'm going to show you my method and you can decide what you want to do. So I've made up a question which I think demonstrates why I like my method. But what I'm going to do is give you 3 minutes. This is not a timer. I actually just picked this up and tried to type 3 minutes into it. It's not going to work for me. So I'm going to time you for 3 minutes, and I want you to see if you can answer this question. Okay, go. I'll write on here that we're doing a 3-minute timer. Okay, we've had 1.5 minutes, so I'm going to add the answer here, and you can see if you're right, and if not, you can try and find out what's gone wrong. Okay, right. So I'm going to go through my method. I'm not going to ask you to comment on whether or not you got it right, whether or not it's okay. I'm just going to show you my method, and then you can ignore me completely, or you can give it a go. So this is the way that I teach to do it. First step is always shift sign or shift cos or shift tan on your calculator. So it's literally calc, shift, sign, like inverse sign basically, of 0.3 in this case. And that gives you solution 1. There are only 2 solutions. Solution 2 is a simple rule, different rule for sine, cos, and tan, but simple. So if it's sine, then solution 2 is 180 minus solution 1. Like we've got sine here in this question. If it's cos, then solution 2 is minus solution 1. So if solution 1 is negative, it's just the same but positive. And if solution 1 is positive, it's the same but negative. And if it's tan, then solution 2 equals 180 plus solution 1. So far, so good. You don't have to do any thinking. You just go shift, sign, blah. That's your first answer. 180 minus equals, that's your second answer. You've got your 2 answers. There are only 2 answers, the end. Okay. Now, obviously, there are more than 2 answers, but everything, they are the stem of everything. They are basically the only 2 answers. It's like, well, it's not like, it's saying we're on a circle and the height above the x-axis is 0.3. Where are we? Here's the circle. There's the x-axis. The height above the x-axis is 0.3. That's what sine means. It means the height above the x-axis. Where are we? There's only 2 places we could possibly be. But because it's a circle, we might have spun round. So this is solution 1, that angle there. That's solution 2, that angle there. But I could just like, I could have my pen like this and I could go spin, 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 spin as many times as I like. As long as I end up in one of those 2 places, that's still a solution. But they are all basically the same 2. So when you've got your 2 solutions, then you can make your list. And you make your list by taking solution 1 and either adding or subtracting 360 to your heart's content. And you get solution 2, and you add or subtract 360 to your heart's content, and then that's the end. Now, number 4, I've deliberately called finally, not number 4, because this is where students tend to go wrong. They tend to mix up step 3 and the final step. So what students will do, and I see this all the time in exams, is that they will do the inverse and then get the first solution and then take off 24.05 times by 15 divided by 4, and then try and get a list of other solutions. No, that will never work. We need to do this thing that I'm going to say last, absolutely last. So the last thing we do is rearrange to get x's. That's the very last thing. So I'll show you it in action very quickly on this example. I'm going to do shift sign or inverse sine of 0.3 on my calculator. Shift sign 0.3 equals, okay, 17.45, blah, 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 blah. I'm going to get that's my first solution. Second solution is 180 minus that. 180 minus that is 162.54, blah, blah, blah. Now, what I'm going to do now is generate my list. The list is 17.45, blah, blah, blah. I'm not going to take any 360s off because my final answer needs to be bigger than 3,200. So I'm just going to add some 360s on for a while. So I'm going to take my 17.45, keeping lots of decimal places, add on 360, 377, blah, blah, blah. Add on 360 again, 737.45, blah, blah, blah. Add on 360 again, 107. It's not hard, is it? Literally just press plus 360 equals blah, blah, blah. And again, I'm a bit bored now, and you literally just keep going till you're a bit bored. So I'll take the other one, solution 2, and 102.54, but keep loads of decimal places. Add on 360, 522, blah. Add on 360, AA2, blah. Add on 360, 1242, Right, bit bored, stopping now. And now I'm going to do the final step. So the final step is that what I have found there, that list, they are not x's. They are 4x over 15 plus 24.05s. That's what they are. They are these things here. That's what I have found, a big long list of those things there. So what do I need to do to them? Let's say I call these ones alpha. They're my alpha values. So each alpha is equal to an x times 4 divided by 15, add 24.05. So if I rearrange that, if I take something from the list and I subtract 24.05, and then I times it by 15, and then I divide it by 4, then I'm going to get x. So I'm undoing that angle to unpick it, but right at the end, right at the end, it's the final step. So literally just sit here. Let's just try some. I'll try that 1242 first. 1242. Keep lots of decimal places. Don't do premature rounding. Take off the 24.05. Times it by 15. Divide it by 4. I get 4,569. 0.3375. That's what that one turns into. Okay, that's bigger than 3,200. I'll try the next one down. 882.84. What was I going to do? Minus 24.05. Times it by 15. Divide it by 4. 3,220.4625. Okay, let's try the next one down. Try that one, because this isn't the first one. When you try the 522, it comes out a bit bigger, a bit smaller than 3,200, so that one's no good. So I want something around 882, so I could try this one, but actually comes out a little bit too small. This one comes out bigger, so that's the one I want, and that turns into this. Okay, now, how come that's wrong? How come I did 882.8, I really did, 882, let's see if I typed it in wrong, 0.84 minus 24.05 equals, times 15 equals, divided by 4 equals 3220.4625. But I told you that the answer was 3219.346. That's the correct answer. So why am I wrong? What did I do? Aisha, perfect. The thing I kept saying not to do, I did. The thing I kept saying, but don't just use 84 there. Don't just use 45. Make sure you use a load of decimal places. I didn't, because I couldn't be bothered to type them in, and that's why we don't. But look how much difference that made. Yeah, just because I rounded early at this stage, I used 2 decimal places to jump forward and I used 2 decimal places to do the conversion. It's made a big difference, 3220 to 3219.3. It's a big difference. So it's a really, really important thing to learn. That's why, you would not believe how many people I mark the exams and they know exactly what they're doing, but they drop all the accuracy marks because in this exact scenario, they've used 2DP in their calculator. Okay, I would like you to solve this one yourself in 2 minutes, max. And I'm going to write down my list of instructions at the side, and you can try my one if you like. Okay, 2 minutes. Okay, that was 1 minute. So now I'm going to write down the answer for you and you can see if you've made mistakes and if so, try to fix them. We're looking for total accuracy here, otherwise you wouldn't get those final marks. They're accuracy marks. .30 more seconds, and this works with sine or cos or tan. Literally the only change is in the second step. So if it's cos, you don't do 180 minus, you just whack a minus on or take the minus off. And if it's tan, you do 180 plus. And second years watching this as well, this works really well, especially when you're doing harmonic form questions, or cos x plus a. Really helps you to get the actual final answers right. Accuracy in this topic is the biggest cause of mistake, of lost marks. Okay, 5 seconds. Done. Does anybody want me to do this one? Does anybody get the answer wrong and not know why and want me to go over it? Or are we happy moving on to the next question? If you're completely don't know how that answer came about, 286.26, then I'm happy to run through and do the method. It only takes 2 seconds when you do it my way. But otherwise, I think we'll move on. Okay. There is a lag, but I'm going to assume that you're all okay, unless I see some chat popping up later to say that you're not. So that's skill number 1, how to solve an equation, really, really important. The only things you have to know are that you can replace sine squared theta with 1 minus cos squared theta whenever you want, that you can replace cos squared theta with 1 minus sine squared theta whenever you want, and that you can replace sine theta over cos theta with tan theta whenever you want. Okay, so I think what I'll do is, those of you who were happy with the last one, write this down. 5 cos 2x minus 4 sine squared 2x equals 2. And I only want the solution between 180 and 360, which actually I didn't write down. So I'll have to actually do this one myself. Meanwhile, I'm going to go back and go through the last one, okay? So if you were fine on the last one, write this down. 5 cos 2x minus 4 sine squared 2x equals 2. Solution between 180 and 360. I am going to go over this one, okay? Right, step 1, I do shift sine of 0.6. Shift sine 0.6 equals. And I'm going to use lots of decimal places, not like I did last time, so that I don't prematurely round. That's my solution 1. My solution 2 is 180 minus that. Now I'm going to make my list. So I'm going to take solution 2, since it's in my calculator, and do plus 360. Plus 360 equals. That'll do. I've got bored quickly with this one. You can always go, if you realize you haven't done enough, you can just go back and do some more. 36.869897. Right. I think probably the quickest way for me to get to that is to do shift sine 0.6 again. Plus 360 is 396.86989. Being really careful not to round stuff. That will do for now. Okay, let's now undo the substitution. Not that I made one, but theta over 2 is what I found. If I call these ones alpha, then theta divided by 2 is what I have found. I've found the angle alpha over 2. So how am I going to get my thetas back? I'm just going to double them. So which one do I want to end up between 180 and 360. So I think the one I'm going to double is, no, that wouldn't work, would it? That would be like 6072 or something. That wouldn't work. I'll do this one. 143.13010. And like, say I did do on my calculator 36.8698 times 2, and then realized it wasn't between 180 and 360. What have I lost? Nothing. Half a second. Anyway, 10130.102. 4 times 2 is that answer. Hooray! Easy, right? So good idea for today, an action hour, go back to this and just practice it a little bit. It's such an easy peasy technique. I think it's great. Right, those of you doing this one, I'm going to run through it super duper quick. What we're going to do is we're going to replace that sine squared with 1 minus cos squared, but put it all in brackets because we're going to have minuses and things go wrong. Remember, in maths, people lose marks not because they didn't know what they were doing, not because they didn't learn it, not because of anything like that, because they knew everything, but these little predictable slips happen. And there's a minus sign there, and there's going to be a minus sign when I replace the sine squared with 1 minus cos squared. So I'm just being super duper careful. Now, the other thing to remember is it's cos squared 2x. Sine squared 2x is 1 minus cos squared 2x. 5 cos 2x minus 4 plus 4 cos squared 2x minus 2 equals 0. So we've got a quadratic. It's a hidden quadratic. It's not very well hidden, but it is a hidden quadratic. It doesn't really look like a quadratic, but if I replace all of the cos 2x's with a p for a minute, 4p squared plus 5p minus 6, now we can see that it's a quadratic. So what I would probably do at this stage is because of the 4 at the front, I'd probably just use the formula. Minus b plus or minus the square root of b squared. B squared minus 4ac is negative over 2a, p equals, boom. Minus 5 add square root 25 plus 16 times 6 over 8 is 3/4. Or using the minus, it is 2, minus 2. Oh, here's an important, I did think that was, I did say 2, but I did actually think it looks a bit like a 1. This is a common cause for mistakes in exams, can't read own writing. Oh, okay. Everyone that's been working with TT previously, what would I do now if I had misread my own writing and thought that was a 1? What would I do with that fact? With the fact that this happened? That I can't read my own writing, that my 2s look like 1s. What I'm going to do is go to my FFS journal. We've all got an FFS journal, and it is building up a little list of things that really did happen in when we were doing maths. It's frustrating fails and slips, or you could think of 3 different words that start with F and S, if you like. Just have it as a piece of paper or a little book, or an iPad screen, or a Word document, whatever you like. But just always, if you get into the habit of jotting them down in your journal all the time, then I promise you, you will start to find yourself being a lot more accurate in maths. Okay, so when you do a question like this, this is very, very important. There is going to be a mark for saying no solutions. And the reason for no solutions is that cos x is always between 1 and minus 1. So cos 2x, which is what p is, equals minus 2 has no solutions. Now that is a mark. It never used to be a mark in the old spec. In the old spec, you could just not worry about this and move on and just say cos 2x is 3/4. And then go on and solve that equation in the way that we've just been talking about. But in the new spec, you would drop a mark if you do that, okay? So this is an A1 mark, or sometimes it's a B1 mark. Anyway, it's a mark. So don't throw away that mark. Anytime in any situation, not just trig, that you solve an equation, particularly a quadratic, you get 2 solutions out, but one of them you're not going to bother with. You have to say why you're not bothering with it. And that's a little bonus mark, okay? Next. Oh, wait, I wrote this one wrong. There we go. So what's going on here? Why is this an important one for me to show you? Now, we're not going to go through the whole thing all the way to the end and solve it all, because obviously, even after you've done all of this work in trig, using this or this or this or doing all of your work, you then end up in this situation where you've got something that looks like that. So you've still got all of this work still to go, okay? So they're huge, they're really, really big and important. The first step is fiddling around, using these rules, getting it down to the point where you're solving an equation and then solve the equation. So with this one, I'm going to just get it down to that point of solving the equation. So we can divide both sides by sine 2x, and then this is one of those situations where it doesn't say tan 2x, but I've got that fact in my head that sine x over cos x can be replaced with tan x, or vice versa. Okay, so therefore I can do divide by cos 2x, and this is usually where this comes from. Usually you won't see sine x over cos x, you'll create it yourself. The cos x cancels with the cos 2x, cancels with the cos 2x, and then the sine 2x over cos 2x here, that can be replaced with tan 2x. And now we can divide both sides by 3. And then we're in the situation we were in a little while ago. Okay, so this is what the trig is like. It's about manipulating what you're looking at, and you've only got these 3 things. So whatever you're looking at, it's either going to be sine x over cos x is tan x. Either you create that and then write tan, or you change the tan x to sine x over cos x, or you're replacing sine squared x with 1 minus cos squared x, or you're replacing cos squared x with 1 minus sine squared x. Now, usually that's not where students lose the marks. Usually where students lose the marks is when it comes down to solving the trig equation, right at the end, because of the accuracy issues, okay? Okay, one more style for you to look at, which is a proof. Now in a proof, it's exactly the same. We still only have 3 rules. Sine x over cos x is tan x, sine squared x is 1 minus cos squared x, and cos squared x is 1 minus sine squared x. We only have those things. And really, it's just a case of confidence, just fiddling around with it and seeing what happens. So you have a go at this I'll give you a couple of minutes to get ahead of me, and then I will catch you up. All I want you to do is expand the left-hand side. That's going to be the hard bit. Then when you've expanded the left-hand side, see if you can tidy it up. Just like collecting terms, fiddling around with it, tidy it up a little bit. And then when you've tidied it up, pull out the common factor of 2, which should be there. And then when you've done that, factorize. Okay, I'll give you 2 minutes to get ahead and then I'll join in. 20 more seconds. If you got yourself in a tangle, have a look at my solution and see if you can unpick what's going on there. All right. Hope you enjoyed that one. I think that was a fun one. Now I've got something really important to say now. Really, really important. There's a lag, obviously, which means that I was kind of waiting during this one for somebody to say something about this one. Because I did something really, really, really bad here deliberately to see if anybody would pick it up. I did something that students all across the country do in equations. Oh, well done, Rathib. Excellent. It's nice when you do a proof. I think proofs are quite nice things to do because you take one of the sides and you just start like kind of like doing it and sort of trying to manipulate it. And then suddenly it pops out and it's the best feeling. I love it. Patricia, you're completely right. I didn't solve this fully, so I didn't actually go on and get the x's. That is completely true, but that is not the big bad thing that I did. There's a really bad thing that I did, which I'm going to create a little monster here of badness. I don't need to think about the range, no, because you know, when we were talking about how to solve this, the method that I showed you, you don't need to worry about the range, do you? If we go back to this method that I was showing you, you collect together your list and then you rearrange them to get what you want. There was no consideration of range anywhere in this method. That's why it's so nice and simple. Yes, we have, Tangina is completely right. We have not got all the solutions, even if we solve this, because you cannot divide through like this. Let's get his other arm there. This, no, you can't do this. What about the possibility that sine 2x is 0? Well, number one, if sine 2x is 0, that solves the equation. 3 lots of 0 is 4 lots of cos 2x times 0, correct? And also, when you blindly like crossed stuff out and divided through, did you think that you might be dividing by 0 there and causing the whole universe to explode? No. This is really important. Never, ever divide through if there is any chance that the thing you're dividing through by could be 0. So in the marks, there is going to be another mark. There's going to be marks for solving tan 2x is 4 over 3. And then there's going to be marks for solving sine 2x is 0. Really, really, really important. Okay. Now, I didn't have another one. I want to go back to the beginning and talk about the playlist for trigonometry. We've still got 10 minutes of our action hour. So this is going to be the final 10 minutes pulling it together and thinking how to go forward with this particular topic. Okay. Sketching the graphs. Well, you can just learn these graphs. Sine looks like that, and cos looks like that, and tan looks like this. Tan is usually the worst to draw because of the asymptotes, like that. Actually, there's another one. This is 180. This is 360. Yeah, it looks like that, from 0 to 360. Oh, excellent. Sorry. Yeah, never cross things out at random. It's about thinking about dividing. It's never divide by 0, but we don't think of it as dividing by 0. We think of it as crossing out, which is why our brains don't alert us to what we're doing. The graphs, is there an easy way to remember them? I don't think so. I used to make my students have whiteboards and at the beginning of the lesson, draw it, rub it out, draw it, rub it out, draw it, rub it out. And we did that for a couple of weeks and then they could all do it. So it's just a case of getting them into your brain, really. So the other thing that I'm going to come back to, this final thing, we've talked about solving the equations. I've shown you my method of doing it. You can have a look at this video 33. I've made that previewable. So if you go into the content guide and look for number 33 of the AS, that you can watch that and make some notes. And graph transformations of sine and cos and tan might be something that you need, but basically, so long as you've got these 3 basic graphs in your head, then it's just a case of graph transformations. The big thing really is the understanding what sine, cos, and tan actually are. Now, you don't need to understand what sine, cos, and tan actually are in order to use the method I've shown you for solving equations. If anything, it makes it worse. So when you've got an equation like this, or the other ones that we looked at where we're solving something like that, it doesn't help in any way to be thinking about what sine, cos, and tan actually are. It's just a method you can follow, it's algorithmic, and it literally just produces the right answers every single time. So I don't think it helps to think in these situations, or when you're doing a equation like this, or when you're doing an equation like this, or when you're doing a proof, doesn't help. But for example, if you're doing something like sine of 180 plus x. Now in the second year, you learn a formula for that, but in the first year, it's like, what is that? I don't know what that is. And if you understand what sine and cos and tan actually are, if you always come back to this understanding whenever you're in a tricky situation, it can really, really help you. And it shows as well why there are only two solutions to the equations. So imagine a circle, it's got radius 1, and you put a dot somewhere on that circle and you join it to the origin. Okay, the angle is there. This is the angle here. Or you could go the other way and make it negative. This is the angle I'm talking about. Or you could go round and round and round and round and then stop. So you could have a huge positive angle. It'd be a million trillion because you've just spun round a load of times, but you end up with an angle. If you want to measure sine of an angle, what you do is you find out how far the dot is from the horizontal axis. That's sine of an angle. That one will be negative because it's below the axis. That's what sine of an angle actually is. Sine of 472. You go round and round and round to 472, and then you see how far you are from the x-axis. For cos of an angle, you see how far you are from the y-axis. So that would be positive because that's to the right. Anything to the left would be negative. And for tan of an angle, you measure the gradient of the line. So here's our line, and it's the gradient of that line. That's what tan of an angle is. So that knowledge and that understanding, it really, really helps you to be able to very quickly work out what the connection is between two things. It also helps you in the second year, so if any second years watching, when you have to do things with inverse trig functions. So you might have to do arc sine of cos of 60 or something like that. Or maybe you do tan of arc cos of a half or something. So those types of questions that you don't worry first years, this is second year stuff. But that basic understanding of what sine, cos, and tan are measuring could really help you out. Okay, we have done well. We have got 5 more minutes of our action hour. So if anybody wants to ask me any questions about the trig, then go ahead. If not, we're going to call this action hour to a close. You can decide what you're going to do, whether you want to go and see those videos, make notes on them. But I would say really for trigonometry, your big, my advice to you, my big advice to you is what I'm trying to say, is to practice it. You don't have to know very much at all. Everything you need to know is on these slides. What sine, cos, and tan look like, what sine, cos, and tan actually measure, the fact that you can do proofs by swapping stuff. Rasib, you don't ever need to do the range if you do my method. I know what you mean by find the range, but if you do this method, you don't need to find the range at all. You get your list by going add 360, add 360, add 360, minus 360, minus 360, minus 360. And then each of these individually turns into an X. Same thing we did here. Here's your list. And then each of those individually turns into a theta, and then you just decide which ones you want. This question said, I only want that one. So you have a look at the question and you see which ones they want, but you never need to use the range. Never at all. Okay, is everybody okay? knowing where everything is in the exambulance and how to get to the stuff that you need for today, cool. I will be back I'll be back in 10 minutes for the second years. We're going to do loads of differentiation. And for first years, I'll be back tomorrow. I think tomorrow we're going to do linearizing data with logs, I seem to remember. And everything you need for trig is available now in the content guide, so take a look at that. And I'm also doing from 4 till 5 every day a study with me. So if you've got maths work or literally any work at all set by your teachers, you might like to come along between 4 and 5, and we just do headphones in, focus. It helps me to stop procrastinating. It genuinely does, because I know that at 4 o'clock I've told you guys I'll be working, so it might help you as well. This, Caitlin, this is all maths boards are identical. Their specifications were not written by them, they were written by the government for maths, not like other subjects, and they are all literally the same. Yeah. There is one difference, which is only relevant for the second, well, no, that's a lie. There's two differences. One difference is the large data set. So the large data set for each board is different. And then every year or so, they're going to change their large data set as well. So large data set being ignored, the only difference is in the second year. In AQA, the topic's the same, moments, but in AQA, they've decided that they won't do ladders. So they will do things like a seesaw, and they will do things hanging for moments, but not a ladder. Whereas edXL and OCR do ladders. And the other thing is the continuity correction. Again, that's for second years. So the continuity correction is used for when you approximate a binomial distribution with a normal distribution in stats. And AQA, they've said we're not going to bother with the continuity correction, whereas AQA and edXL do. Other than that, they're the same. Okay. How do you appeal if you need to? We don't know yet, but basically what we think at the moment is most likely is that the appeal will consist of applying to do the exam. So the appeal will be you put your name into the hat to do the exam in September. That will be the appeal. Okay. Right. Time is up. We're going to take a break now, and I'm going to get up and walk about, stick to the rules of action hours, and I will see you tomorrow.